Okay, good morning to all of you. In our last class, we have been discussed solution of non-homogeneous linear differential equation with constant coefficients by using method of variation of parameters in detail. The theoretical part we have discussed here, and uh, on the base of this theory, we have been solved four important questions. This is your first question, second question, uh, third question, and this is your fourth question. And I given two questions to you that you have to solve by yourself. And today in our class, in this class, we are going to discuss operator method to solve non-homogeneous linear differential equation, or operator method to solve the yp integral parameter. So before we have to start how we have to use the operator method to solve NHLDE, or to find out yp integral particular integral by using operator method. First we have to discuss these two problems whatever I given to you in our last class, and then we are going to discuss another question by variation of parameter method. Then we are going to discuss operator method to solve yp particular integral. Okay, so here we are not going to go with detail. I am going to give the hints. That means here I am going to consider this question, and we are going to focus only or in short I am going to discuss these two questions. Just follow me. See, this is your d square y by dx square plus 2 dy by dx plus y e to the power minus x log x. So its corresponding log auxiliary equation will be how much? M square plus 2m plus 1 equal to 0. Okay, that means this is your m plus 1 whole square equal to 0. So m we found two roots, that is your minus 1 and minus 1. So two same roots means the complementary function will be c plus dx e to the minus x, right? That means y1 will be e to the minus x, and y2 is your x into e to the minus x. So if we are going to consider the Wronskian, that will be e to the minus x, and this is your x e to the minus x, and this derivative is nothing but is your this is your minus e to the minus x, and this derivative will be x to the power x into e to the minus x. This is minus x e to the minus x plus e to the minus x. So its Wronskian will be, see, if I am going to multiply this and this, then this will be minus x e to the minus 2x, and this will be e to the power minus 2x, and then minus of minus plus of this one, so only we can get e to the minus 2x is your Wronskian. Okay, now we know that the yp for this case y1 c1 plus y2 c2, and here c1 is nothing but minus integration of y2 source function dx by w Wronskian. Here source function x is given as e to the power minus x into log x. So we have to substitute y2 is nothing but x e to the minus x e to the minus x into e to the power minus x log x dx by Wronskian is your e to the minus 2x. Substituted, so minus is here. So here you can see e to the minus x e to the minus x. So e to the minus 2x by e to the minus 2x got cancelled. So we found x log x dx. So minus x log x dx. So x log x dx integration already we have been discussed in our last class by using by parts. You can do it. Here you can check here in the question number. You just follow in your question number, this one, question number 3, last question number 3. Here x log x integration is nothing but log x into x square by 2 minus x square by 4. That I am substituted over there, right, directly. So this will be minus log x square by 2 minus x square by 4. This is nothing but c1. If I got the c1, the corresponding okay, c1 here we found. Now c2 we have to find out. C2 is nothing but C2 we know that y 1 x by w into dx, right? So y1 is nothing but e to the minus x. So e to the minus x, x is nothing but e to the minus x log x by e to the minus 2x into dx. So here e to the minus 2x at the numerator e to the minus 2x divided by e to the minus 2x. Got cancelled. We found only log x. Okay, log x dx. Now log x integration is nothing but this one. How it is? You just consider the islet. That means you just integrate log x by using by parts. So here inverse logarithmic arithmetic trigonometric exponential. So here you can consider only log x means 1 into log x dx. So here 1 you can consider as one arithmetic. Okay, so log x is your first function. So inverse logarithmic then arithmetic. So log x will be considered as the first function. So log x integration of dx then minus derivative of the first function 1 by x integration of the second function, that is your 1 x dx. So x got cancelled. So this will be log x and integration of this one dx will be x, and here x got cancelled x. So take common x from both the terms, we can get x into log x minus 1. So we got c2 and this is your c1, right? So now the yp will be equal to y1 into c1. y1 means e to the power minus x into c1 means this one minus log x into x square by 2 minus x square by 4. Then y2 c2. y2 is nothing but x e to the power minus x. c2 is nothing but x log x minus 1, and then the general solution will be y equal to yc plus yp. Okay, complementary function already we found like this. So I suggest that here I discussed all the steps, but you have to write down in your note with all the procedure. That means like this in the note you have to write in this format. Okay, here I discussed what will be the yc, what will be the yp, c1, c2, all the things I have discussed, but in the note I suggest that you have to write with all the steps. Okay, now we are going to go for the second question. This one, d square y by dx square plus y sec x into cosec x. So here you can see the auxiliary equation is nothing but, here you can see this is your m square plus 1. Okay, d square y by dx square plus y is there. That means its auxiliary equation is nothing but m square plus 1 equal to 0. So m equal to plus or minus I. So this is in the form of imaginary roots, two imaginary roots, that is your alpha plus beta I. Here alpha equal to 0, beta equal to 1. So hence if imaginary roots, that means the yc will be c cos x plus d sin x, because in general this is e to the power alpha c cos x plus d sin beta x. Okay, beta x. So here beta value is 1 and alpha value is 0. So obviously c cos x plus d sin x is our complementary function, right? So this is your y1 is your cos x, y2 is equal to sin x, sin x. Okay, so Wronskian will be cos x sin x, y1 y2, and derivative of cos x minus sin x, derivative of sin x cos x, and its Wronskian will be 1. Now we know that yp particular integral is nothing but y1 c1 y2 c2 by using this variational method. So c1 is nothing but minus y2 x source function by w into dx minus here y2 is nothing but sin x into source function given that sec x into cosec x. So sec x into cosec x divided by 1 into dx. So here you can see that sin x and cosec x got cancelled, because sin x is nothing but 1 by cosec x. So cosec x got cancelled, only we got the sec x minus sec x. Now we have to integrate sec x. Okay, how we are going to integrate sec x? See, here minus is minus. Okay, now we are going to be multiply sec x plus tan x in the numerator and divide sec x plus tan x in the denominator, right? So sec x is there into sec x plus tan x divided by sec x plus tan x dx, right? Now you just multiply sec x with sec x, sec square x plus sec x into tan x, sec x into tan x dx by sec x plus tan x, right? Now we have to put t equal to sec x plus tan x, right? So dt will be uh, how much? Sec x derivative is nothing but sec x into tan x derivative is nothing but sec square x. You just see here that the derivative of this one is in the numerator, right? So we can write this is dt is nothing but this much into dx, right? So instead of this into dx, we can write dt by t. So dt by t integration is nothing but ln t log t. So minus is there, minus ln t minus ln t is nothing but sec x plus tan x, sec x plus tan x. So integration of sec x is nothing but ln sec x plus tan x, minus is there, you have to put minus. Okay, this is our value of c1. Now we are going to go for the c2. c2 is nothing but y1 x by w into dx. y1 is nothing but your cos x, and this is your source function capital X, sec x into cosec x. You just put, so cosec x sec x got cancelled because cos x into sec x. So 1 by sec x both are got cancelled, only we got integration of cosec x dx, right? And the integration of cosec x dx is nothing but log cosec x minus cot x. Okay, you can put mod, or you no need to put mod, no problem. So this is the log cosec x minus cot x is the integration value of cosec x. How it is, here I don't, you just see it, integration of cosec x. So here I multiplied cosec x minus cot x and divided cosec x minus cot x. Just multiply. This is cosec x cosec square x minus cosec x into cot x divided by cosec x minus cot x, okay, into dx. Now put t equal to this much, cosec x minus cot x. This is x cosec x minus cot x. Now dt will be cosec x derivative, we know that minus cosec x into cot x. Okay, derivative of cosec x is nothing but minus cosec x into cot x. Cot x derivative we know that cosec square x then dx. Okay, here you can see that minus cosec x cot x plus cosec square x is in the numerator here. That means derivative of this one is in the numerator. Okay, that means here if I am going to take this one as t, then this is nothing but dt. Okay, so dt by t integration is nothing but ln t. Okay, so t I considered cosec x minus cot x, so ln cosec x minus cot x. This is the answer of cosec x integration. So I suggest that you just remember these two important integration. Cosec x is your cosec x minus cot x, ln cosec x minus cot x. No need to derive all the things always in your exam. Likewise, you have to remember sec x integration is your ln sec x plus tan x. It will be easy for you that to reduce the step. Likewise, here log x integration, you have to remember this one. Okay, and x log x integration, log x into x square by 2 minus x square by 4. So these integrations you have to remember. It will be useful in your semester exam. So no need to derive this integration. You can direct write the integration of this one will be this one, right? So here I discussed the two problems. See, here we found in this question C1 this one, C2 is this one. So YP is your Y1 C1, Y2 C2. Y1 already we found, this is your cos x sin x, you just multiply, and YP you can get, and Y is nothing but YC and YP. So here I discussed all the steps regarding YP, and I suggest to all of you that you have to write in your note in proper format in which way we have been discussed the problems in our last class. Okay. Now we are going to go for the next question. Uh, that is, you solve d square y by dx square minus y equal to 2 by 1 plus dx by method of variation of parameter. This is one of the important question. Here, given that d square y by dx square minus y equal to 2 by 1 plus e to the x, as this is the function of x, so this is a non-homogeneous linear differential equation. So the solution of non-homogeneous differential equation is yc plus yp, and auxiliary equation of this one is m square minus 1 equal to 0. So m equal to plus or minus 1. For that, yc is nothing but c into e to the x plus d into e to the minus x, because the two roots are different. One is minus 1 and another is plus 1. Okay, the two different roots, or you can write plus 1 minus 1. One is plus 1 and another is minus 1, the two distinct roots. So complementary function will be c into the e to the x plus d into e to the minus x, because, and from this complementary function we can found this one is your y1, that is your e to the x, and this one is your y2, that is e to the minus x. So by considering y1 and y2, the Wronskian will be equal to minus 2. Okay. Now we have to find out yp. Yp, that means particular integral, that is nothing but y1 c1 plus y2 c2. Now we have to find out the c1 and c2. Here c1 is nothing but minus y2, the source function, divided by Wronskian into dx. So this is minus the y2 is nothing but e to the minus x, right? So e to the minus x by Wronskian. Wronskian is nothing but minus 2, right? You just substitute minus 2 here, and here minus is here, here also minus is here. Okay. And the source function x is nothing but 2 by 1 plus 2x, 2 by 1 plus 2x dx, right? So here minus minus got cancelled, 2 got cancelled, we got that e to the minus x by 1 plus e to the x dx. Now here e to the minus x can be taken to the denominator, that is your dx by e to the x into 1 plus e to the x. So I just written in this format, that you just consider 1 by separating the two terms. Okay, that is 1 by e to the x minus 1 by 1 plus e to the x is nothing but this one, 1 by e to the x into 1 plus e to the x. See, you just add it, sorry, subtract it. The denominator will be e to the x into 1 plus e to the x, and the numerator will be 1 minus e to the x minus e to the x. So got cancelled, so 1 by e to the x into 1 by e to the x. So this can be written as in this format, okay, into dx. Now here we can get the two integrals, that is your e to the power, here e to the 1 by e to the power x, that means e to the power minus x dx, and another one is minus 1 by minus 1 by 1 plus e to the x. Okay, but here I done one thing. See, consider 1 by 1 plus e to the x. So in the numerator I divided e to the x, and denominator I divided e to the x. So that is 1 by e to the x, 1 plus ex by e to the x. Then what it will be? E to the power minus x by here. Here you can see each term I divided e to the x. So this will be e to the minus x plus 1, right? So 1 by 1 plus x can be written as e to the minus x by e to the minus x plus 1. So 1 by 1 plus x can be written as e to the minus x by e to the minus x plus 1. Why are you doing this one? Because it will be easy for us to do the integration. So here you can see integration of e to the minus x dx will be minus e to the minus x. Now you can see that this is the denominator and this is the numerator. The derivative of this denominator is in the numerator. So hence integration of e to the minus x by e to the minus x plus 1 will be nothing but ln log e to the minus x plus 1. So we found this is your c1. Now we are going to go for the c2. c2 is nothing but y1 x by w into dx. y1 is nothing but how much? E to the x. So e to the x by w. W is minus 2, and source function is nothing but 2 by 1 plus e to the x into dx. So here is minus 1, minus is there, so 2 got cancelled, minus e to the x by 1 plus e to the x into dx. And here the derivative of denominator is in the numerator, so the integration will be minus ln 1 plus e to the power x. Therefore yp will be what? Is your y1 c1. So y1 is nothing but e to the power x, e to the power x into this one. Okay, and y2 is nothing but e to the power minus x, e to the power minus x, e to the power minus x into uh, minus ln 1 plus e to the power x, right? This one. So just simplify, we got this one, e to the power x into e to the power minus x. So only minus 1, and here e to the power x into ln e to the power minus x plus 1, and then minus, here you can see minus is there, so minus e to the power minus x ln 1 plus e to the power x, right? So the general solution will be complementary function, already we found here, c e to the power x in plus d e to the power minus x, and then yp is this one. So this will be the answer. Okay, so here in this class we are going to be stop over here, and in our next class we are going to discuss about operator method to find particular integral. Okay, so thank you so much for watching this video.